Lesson 1.5 is brought to you by Lego the Green Arrow. I think that's his name. He certainly has a green bow and set of arrows. Okay, so in this lesson, we're looking at the idea of scale and how do we convert units using dimensional analysis, and then how do we use percentages when we talk about scale. So if we want to really simplify this notion of scale here, we're saying, how do we convert something that's in a large form into a small form? What do we do mathematically? And vice versa. If we start with something small, how do we convert it into big form? So I'm going to skip page 57. We're going to jump right into page 58 where we have some problems. So we got this prompt. This is a bobblehead of the author of this textbook. And he says that his bobblehead is a scale of 1 to 13 to the scale model. So it means that this is 1/13 of his actual height. Another way we could think about it is 1 inch of the bobblehead equals 13 inches of the actual height of the person that we're talking about. So in this case, we're told that this bobblehead is 5.82 inches tall. So note we're going to convert this mini-me example, so this small bobblehead, into the actual size of the author of the textbook. And we're supposed to round to the nearest inch. So we're starting with 5.82 inches of the small person. So I'll put that in parentheses, a little s. And essentially what we do here is we say, well, for every one of these inches, we get 13 inches of the height of the actual person. So if I multiply this by the 13 inches of the tall person, and I'll put a little t in parentheses afterwards, we get the appropriate height of our author. Notice I'm introducing you to dimensional analysis. These are inches in terms of the small person, and they will cancel out, and we'll be left with inches in terms of the tall person. So jumping to our trusty Desmos, we're going to take the 5.82 inches of the small person. I'm going to hit Shift 8 for multiplication times the 13 inches for the tall person. That means we get 75.66 inches is the height of our author. Now we are to round to the nearest inch, right? So this is fractions of an inch here at the decimal. So we're going to round to this decimal place. We're going to look at this number. Note that it's larger than 5. So this is he's approximately 76 inches tall. Okay, now we're going to go backwards. So we're going to say if the actual mini-me, in other words, the guy from the previous page, was 32 inches tall and had a bobblehead made at the same scale. So 1 inch of the bobblehead equals 13 inches of the real life person. How tall would it be? And here we're going to round to 2 decimal places. So what I'm going to do here is the same idea. I'm going to do 32 inches of the tall person. Maybe I should use the letter B instead of T. I'm going to change that back up here. And then we're going to now go from the big to the small. So we're going to divide, because every 1 inch of the small is equal to 13 inches of the big version. All right. Again, what we're going to end up here doing is just taking 32 dividing by 13, and that will give us our result, the size of the bobblehead that represents the real mini-me. We get 2.46158, blah, 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 blah. So I will do, let's see, 3 decimal places, 2.46. I'll do 2.4615, and then I'll come back and round that. Because we wanted to do 2 decimal places, that's this place right here. So our final answer is 2.46 inches tall. That's what the bobblehead would be. All right, so we're supposed to write a verbal description of what's the process from going from large to small, or from small to large. Well, if you notice what we did up here, when we go from small to large or small to big, we multiplied by the scale factor. In this case, it was the 13. And then if we go from big to small, we divide by the scale factor. Again, we divided by 13. this should make some logical sense, right? Because when we multiply by things, we're going to end up with larger numbers if we're multiplying by a whole number, which you're always going to be doing with a scale factor. And if we're dividing by something, we're breaking a quantity into smaller